Okay, so hello everyone. I'm Wei-Chou. Today I want to share my CSCIE 63 class final project. My topic is Spark KMEANS. So the background is that we all know that Spark is a well-known distribution platform for big data processing, and KMeans is one of the most popular algorithms adopted in various domains. And that's why in this study we try to combine the both popular things and demonstrate how you can use the Spark to implement K-means. And certainly because K-means is a clustering method, so we also introduce a popular cluster result evaluation index to help you to make judgment whether the K-means is good or not. So let's start talk about the K-means. I know some people may not be familiar with the K-means algorithm, so let's start talk about it. K-means is a very popular clustering algorithm based on the unsupervised learning. When we say unsupervised learning, meaning you don't need to label the data by yourself, the algorithm will actually automatically grouping the data for you and tell you how many group for you in your data based on your input. And how the K-means actually work is actually the simplest way to think about it is that it's basically just partition the data point into K cluster. And in each cluster, you can find a centroid. And basically, when we say centroid, that is the representative data point to cover other data point within the cluster, right? And how the algorithm works is first it will randomly assign the centroid at the very beginning, and after that the rest of the data point will calculate the distance to the centroid, and those data point will associate to the centroid which closest to them, right? And after that, we will try to update the centroid, and once we update the centroid location, you will notice that the distance to the centroid will get changed, right? And the distance should be smaller and smaller, and when it's not going to further small, then we consider the process is converge, and when we converge, the centroid will not change anymore, and that's how you get your final result. That's the description. I know that one diagram maybe better explained than 1,000 words. So in the next slide, we will talk about. We will show you a diagram to illustrate the idea behind the K-means as well. So let's say we start with this diagram. So we have all the green dot is your input data, and obviously we supposed to have a two group, and let's see how the K-means figure that out, right? So first say the K-means will assign a random 2 point as a centroid, and based on those 2 points, you can see the some of the dots because they are more closer to this blue centroid, so we mark it's a blue, and for the data point more closer to the red centroid versus the blue centroid, they will be colored as red. And after that, you can see the centroid will actually start moving. The reason the blue centroid moving off is because you can see if it's moving off, then the distance between the data to it will get much smaller than compared with the previous diagram, right? So that's why the centroid try to move in that way, so it can reduce the distance between other data to it. And the same thing happened to the red centroid. It moved to the higher population area, so it can reduce the distance between the data associated to itself, right? And now you can see once the centroid moved to those locations, video 2